Hi all, my name is Yuri and today I will present our solution at Jigsaw competition in classification text. So I will try to make it interesting for everyone, for starters and for users for advanced users, which we can extract from this speech something interesting. So the main Jigsaw business, it's a technological company which is a part of Google. And it makes a lot of researches in NLP area, which allows to use last technologies in cybersecurity, in filtering bots, in filtering some toxic classification in YouTube, and etc. So they already have a lot of products, and they use it in production in such a big company as Google. The main goal of this competition is to classify toxic comments and to detect some identities. So it's not the problem not only to detect toxicity, but also to understand why. What is the main category of this problem? Also, there were special competition metrics. Creators of this competition used it because it allows to make the proper model for such a hard classification task. It's like a bias AUK score. It consists of overall AUK, overall toxicity, and also consists, second part, it's a subgroup, which consists of three parts. It's subgroup AUK, it's AUK for every category. It's also a little harder metric like background positive, subground negative, and background negative, subground positive. They use it because they want to predict not only, for example, to understand if it is toxic and have this category, but also some cases where model understand what is the category, but doesn't understand its toxicity. So it penalizes model for this misclassification. Also, I would like to present our gym team. It's a super professionals in NLP area. It's Gennadий Штех, which are working with as a NLP researcher. It's Николай Прокопцев, which is working in Mail.ru as a data scientist. And that's me. Our final solution is a blending of a very big models. We started with using some small one, but understood that it's very hard to make a good result, the best result in these models, and that is why we started using some bigger models in this competition. And as a result, it's the first place in public and private leaderboard. They provided very big amount of data. It's around 2 million of samples for train, and around 100,000 samples for test. What is important, that the test set was replaced on another one on a final standing. So it allows to detect some people who overfit on some data and to make the leaderboard, final leaderboard, more reliable for all participants. In data was some hard examples because they were not very complex. They have some normal text which should be classified some way, and also there were very big amount of subcategories, and a lot of them was zeros. So we should handle them somehow, and I will in next speaker will tell about it more. So there was a main columns and also AUX target columns. The main difference is that AUX targets allow us to understand it in a regression way, and identity columns like to understand what is the main problem of this comment. So we started with, how I already said, with some small models like LSTM. We tried to fine-tune it on a proper way. It was hard, and after that we use a bigger model. So we tried to train BERT, XLNet, and GPT-2, and used bucket sequencing collector to make it training faster. Also, for some reason, after we trained these models, we tried to use custom head to make more experiments in the same time, and to aggregate the very big amount of data which was which we got in these models, to blend it in a very interesting, complex way. Also, we use custom mimic laws, because a lot of participants use just simple laws like binary cross entropy and etc. We use the custom mimic laws, which allows to get a closer result to the final metric function. Also, what was interesting is a stochastic weight averaging, when we ensemble models not by averaging their predictions, but by averaging their weights. It allows to get a better result in practice. And as a final, we used rank averaging ensemble. So we just not averaging the predictions of our models, but we make them ranking. So they everything at the same way, and after that we make an average. You can see the weights on the screen. So it's the best weights we could find for this model. Thanks everyone. My part is already ended, and I give the next word to Gennady. Thanks.
Hello to everybody. I'd like to tell about BERT, BERT model, and how do we use it. The first step was to pre-train language model, which BERT is originally is. BERT is autoencoder model which restores some masked sequences which you can pass to it unsupervisedly. So we pre-train a language model on domain texts, on texts which gives us the organizers, and we obtain more more difficult model, more good model for model imena for sorry to model exactly word distribution which is in the data set. Also, there is some nature of BERT is attention model, so you can add some artificial tokens and increase capability of the model, which I describe later in detail. Also, then we just train on classification. Then we apply stochastic weight averaging. I tell about this more. About changing classification head will tell more Nikolai after me. And about freezing he will tell too. So about auxiliary tokens. Most of the participants predict not only the target, but also some auxiliary auxiliary targets, such as is Christian mentioned, is male mentioned, and so on. You can see such columns from here. It's it's given for train set, but not were given for test set. But you can't use it to train to augment your model. So most of the participants augment in such way. They just took some vector representation from CLS token of BERT and then train multiple classifiers for different classes. Our way was different. We just include some additional tokens which were reserved in BERT architecture, tokens from 10 to 1000 200 is reserved, so you can use it for your own purposes. We use it for predict these properties of data set. It allows us to model data more precisely and gives model more ways to predict your target because of attention nature, or it used a lot of data which consists in these tokens, artificial tokens. So the next is about SVA, stochastic weight averaging. It was proposed by Skoltech team very recently. The problem with traditional optimizers is that they oftenly took some bound of optima, but SVA with their averaging most of the time achieves the center of optima, of global optima or local optima. As you lucky, it will be a global optima. It achieves that by averaging some checkpoints at some time. So, for example, you can checkpoint this and this model and average the weights, not predictions, but weights of the model. It costs you nothing because averaging of a model is very fast, and you shouldn't predict you shouldn't run your inference 3 times, but only once for one model, and it increases your performance dramatically. The next part is the next part will discuss Nikolai, please.
So, hi guys. My part of the solution consists of a blend of 3 models. It's 2 XLNets and 1 BERT model. XLNet essentially is the same as BERT model, but it's trained on much larger amount of data, and it's trained using permutation after regressive language model. So we used a little bit preprocessing, delete some emojis, Latin small letters, accents, and standardize some symbols. So in dataset there were a lot of garbage symbols. So for example, there were 7 kinds of quotes, symbols, etc. So we standardize them to make only one symbol of quote. Also, during training, we predicted 15 binary labels, targets, identities, and toxic subtypes. So train from 2 to 3 epochs. From 2 to 3 epochs. The main thing during training was to bucket sequences by length. We did that to use larger batch sizes. So essentially, when you bucket sequences by length, you divide whole your training data set into buckets. So, for example, the first bucket are the sequences with a length up to 16, and the second bucket from 16 to 32. So this way you make sure that you won't lose any computation power. Also, we used mixed precision training. It also allows us to use larger batch sizes. Moreover, after training the model, we choose to change the head of model and train custom head. We did it that way. We predict last 4 layers for classification token for whole training data set. So this way we get we get data set contraining of vectors of size 4K, and we replace head model with multi-layer perceptron. It was 2 layers, and it also had batch norm layers. So the resulting model was fine-tuned on this data set. Moreover, to approximate final metric, we tried to mimic it using this loss. So basically, it looks the same as competition metric. Here we calculate masks, so BPSNS, BNSP, and subgroup masks. Then we calculate binary cross entropy, and essentially, like in metric, we use power mean to weight it. So basically, it's the same as final metric, but we changed AUK to binary cross entropy, and we used a positive exponent in power mean to penalize the worst performing group in terms of binary cross entropy. So this way, we can boost the score of our best model from 0.9441 to 0.9452. So basically, the first score is something like 60th placed, and the second score is something like 15th place in the leaderboard. So this way we can boost our performance. That's it for my part, and Yuri will finish our presentation.
We also would like to share the good ideas from other competitors, and one of them is third place, the user Sakami. He used negative downsampling during training. He deleted samples with normal examples which have no labels at all. It's very, it's very dangerous tactic because it can lead to overfitting. But in this competition, it helps him to improve his score. So if you see that it gives you some points, use it, but on your risk, because it's maybe very dangerous. Also, another good idea from Nikita Pronkin and Ilya Yazepov, also Russian team, they used very interesting LSTM model on char level with some additional improvements. It gave them comparably good score for ensembling, and if we will use it, it will allow us to get a even better score. But we got a small, very little worse result than they have, because we didn't use it on char level and we didn't use their technique. We just used the simple LSTM, even BLSTM and other same architecture, but it gives us a not so good score. That's why we just leave it away and use it in another way, because the competition was like a rocket jump. We started with like 60 place in like half a month before the end of the competition, and we just what to use. And there was a little not so much time, but a lot of models which we would like to try. And we tried XLNet, we tried GPT-2, BERT, we tried custom techniques with them, and also during the competition, good researchers from Google and Carnegie Mellon University published XLNet. It was very stressful because it was very shock for everyone, because it proposed the best result in an NLP area comparing to the other models, and we started to train it. So we use 4v100 to train it, and it gives us a very good improvement for our model. And also from 8 plays, there's another interesting technique. It's multi-sampling dropout. Comparing to simple dropout, when you just with some probability drop some data, it multi-sampling dropout propose when from the exit there are some amount of MLP layers, and from these layers this data is drop out with some probability, and after that it's averaging. So it's just another technique. Maybe it will help us because we just use a custom head with 2 MLP layers. But maybe using this technique it will allow us to get even a better score. But it's maybe not, because we used also stochastic weight averaging, which already proposed some averaging and sampling of the model, and this practice should be tested maybe in the next competitions. Also from my team and from everyone, I would like to tell thanks to ODS AI community, which allow us to meet each other first, second to get interesting ideas, to see new techniques, which was proposed by Nikita Pronkin and other competitors, which published very interesting code with examples in public kernels, and it allows to start us to understand the NLP better, and for advanced users to use another tools for a better score. So it's just amazing. Also thanks to Jigsaw team for this interesting competition. Thanks Kaggle for this ability, and of course, as I already said, Carnegie Mellon University and Google Brain team for XLNet. It was stressful at the beginning, but it gives a very great improvement. Thank you. If you have any question, please ask.
You may ask questions both in English and Russian.
Thank you guys for the talk. I do have a couple of questions. First one, what was your validation strategy? Did you use cross-validation or holdout set? And what was the sampling method? And the second one, how did you come up with the blending weights? Did you use leaderboard? Did you use validation or both?
Test. 1 1 test. Sorry. Okay. So we used only holdout because cross validation is requires too much of computational power. We have 2 different holdouts with my partner, with my partners. So we validate it separately, but after we found some union intersection of our holdouts and tried to validate is our model correlated or not. It was enough. There was 3,500 examples, and it was very noisy, but it was enough to estimate our correlation. And then we just push every single model to public leaderboard and estimate how it good there. And coefficients was proportional to the quality of model on public leaderboard.
Thank you so much. Some more questions?
Yes, thank you for the talk. I have 2 questions. The first one, what is the sense to train both BERT and XLNet if XLNet is actually to the same architecture as you have mentioned? And the only difference is that XLNet is trained on another data set, and that's the only difference. What sense to train both XLNet and BERT? And the second question is, what's the hardware you have used to train such sophisticated architectures like XLNet and BERT, and how much time it took? Thank you.
So thanks for your question. Basically, XLNet and BERT were pre-trained on a different amount of data. So XLNet used 10 times larger amount of data, so it's just better model. So that's why we used XLNet and BERT.
Why have you used BERT if XLNet is better?
So we just try different models and blend them. We train them from different seeds, so this way they were quite different, and we can blend them and get better scores.
Yeah, also it's a common technique to use different models and average them, because they give a little different result, but in averaging it allows us to get even better score.
Yeah, but as you have told, as your colleague did it. As your colleague told, XLNet and BERT are absolutely the same models. The only difference is that BERT is trained on another dataset.
Not the same, but you know.
Yeah, they're not the same because BERT is autoencoder which predicts masked, which performs masked language modeling.
Okay,
Yeah.
I got it. Thank you.
Okay, sorry.
Thank you so much. Еще вопросы? Можно на русском, можно на английском.
Another question is, thank you for the first answer, but my second question is, well, takes place so far.
How much time?
How much time you have?
Okay.
What's the hardware you have used to train such models?
Okay, I had 5 Titan X's, all Titan X's from 900 version of NVIDIA, and one BERT model, large BERT model, trained for a week. And my partner?
So I had 3 Google credits. I started from them. Then I trained a model on 4v100. So one epoch took about 6 hours. So I could train large XLNet models in 12 hours. Yeah.
Yeah.
That's it.
With a very modest configuration like the two 1080 Ti, you can just train like one epoch at BERT medium, like for like a day, like 20 to 22 hours. So it took time to make experiments, like 1 day for model, or even bigger if you will make more epochs.
That's great, because as far as I know, XLNet requires 2 weeks on extremely sophisticated hardware and not 10.
Yeah.
Not
Thank you. We have one more question here.
Thank you for presentation. Could you explain the intuition behind custom mimic laws? Is it your invention or you discovered it on a forum?
So the intuition for custom mimic laws basically is that you first train model to extract relevant features like target identities, toxic subtypes. Then you predict last 4 layers, get data set consisting of 4K vectors, and basically our mimic laws, we've came up with this by ourselves. We just change in metric that was given us by organizers, we change AUK to binary cross entropy, and so binary cross entropy works in the way that the lower the better. So we must penalize the worst performing group. So we change positive exponent in power mean. We change negative exponent in power mean to positive exponent in power mean. That way we penalize the worst performing group. Yeah. So basically it's essentially the same as organizers metric, but with some tweaks to allow use backpropagation. Yeah.
Thank you. Еще вопросы?
Thank you. What do you think about knowledge distillation for large models such as BERT? Maybe did you look at this approach or maybe you know about successful attempts from solution from other teams?
As I know, nobody's used distillation or quantization of the model because it's too hard for the competition and and it drops performance of the model in scores. There is no such a problem as computational time because you have 2 hours. It's a lot, so everybody tries to achieve as much score as they can, so nobody's used distillation. But there's a lot of techniques such as transformer pruning, and so on. So you can use it very extensively and get really good results with a very light model.
Большое спасибо. Остались ли еще вопросы?
Thank you for your work. You mentioned that you dropped all emojis from this data. So as it seems to me, I think it can give some information for classification. Why did you drop it? It was your heuristic, or it was experimentally, or what?
So I dropped only ASCII emojis. So you know, some users posted comments in very strange forms. So like take basic comment and surround it with a lot of ASCII hearts. Yeah. So it makes it basically make no sense. So I drop only some emojis, not all.
Yeah. And also people doesn't use these things to make complex sentences. So they just can, it's like one word, but one word like is overfit. If we will use it and we will just overfit to this symbol, and it will give us a worse score. So we just remove them because some of them, because they was useless in this competition.
Okay, thank you so much, guys.